Hello students, hope you all are going good. Today we discuss about irrational numbers. As we have discussed in previous lecture about the rational number, which is a ratio of two integers like p by q. But in irrational number, a number cannot be expressed as ratio of two integers, or we can say a number which cannot be expressed as ratio of two integers is called an irrational number. So there are examples of irrational number like square root 2, cube root of 7, 2 into square root 5, and so on. We all know that the value of pi is equal to 3.1416 and so on, as the value of pi is in decimal form and the decimal form is non-terminating. So this is also an irrational number. So all non-terminating and non-recurring decimals are irrational numbers. Next, there is one note. A fraction p by q can be expressed as terminating decimal only if after cancellation common factors of p and q, the prime factors of p and q are 2 or 5, 2 and 5. So what is the conclusion here? P by Q can be expressed as terminating decimal if after the cancellation of common factors, the remaining factors, prime factors, may be 2, maybe 5, or we can say both 2 and 5. If these factors are present, then we can express that as a terminating decimal. We explain it with the example. Without division, we have to find out which fractions can be expressed as terminating and non-terminating decimals. So here, without doing division, we have to find out which fractions are terminating and which are non-terminating decimal. So first example is like 9 by 10. Here in denominator there is 10. So factors of 10 are 2 and 5. So 2 into 5 equals to 10. So here prime factors are 2 and 5 both. So it can be expressed as terminating decimal. Next example, 10 over 44. So we can make it in lowest form. We know 2 into 5 is 10. By dividing by 2 in numerator and denominator, we get 2 5s are 10 and 2 22s are 44. So here in denominator there is 22. So factors of 22 are 2 into 11. In these factors, there is prime factor 11 other than 2. So, this can be expressed as non-terminating decimal. If here there is 2 alone, we can express it as terminating, but here other than 2 there is 11, so we can express it as non-terminating decimal. So what is the conclusion? If there are prime factors in denominator are 2 or 5 or 2 and 5 both, then that fractions can be expressed as terminating. If there is factor other than 2 or 5 in denominator, then that fraction can be expressed as non-terminating decimal. So our next topic is insertion of irrational numbers between rational numbers. Let us take an example. We have to insert two irrational numbers between 8 and 10. So, to find two irrational numbers, first we do the square of 8. We know 8 square, which is equal to 8 into 8 equals to 64, and 10 square is equal to 10 into 10, 100. So we find any two numbers between 64 and 100 which are not perfect squares. So between 64 and 100 numbers which are not perfect squares, like we have 70 and 80. 70 and 80 both are not the perfect squares. So 70 and 80 lies between 64 and 100. Now taking the square roots, square root 64, square root 70, square root 80, then square root 100. We take square roots here because we have to find irrational numbers between 8 and 10, and the square root of 64 is 8. So, and square root of 100 is 10. So here 8, square root 70, then we can make the factors here of 80, 4 into 4 into 5, and square root 100 is 10. 8 less than 70 square root less than 4 square root 5 less than 10. So here two irrational numbers between 8 and 10 are square root 70 and 4 square root 5. Next we take another example. We have to insert three irrational numbers between 3 square root 2 and 2 square root 5. So what we do first is we take the squares of 3 root 2 square, which is equal to 3 square is 9 and root 2 square is 2. So 9 into 2 is 18, and square of 2 square root 5. 2 square is 4 and root 5 square is 5. 4 into 5 is 20. Now we have to insert three numbers between 18 and 20 which are not perfect square. So 18.5, 19 and 19.5 are three such numbers. Then we write it as 18 less than 18.5 less than 19 which is less than 19.5 which is less than 20. Now taking the square roots, square root 18, square root 18.5, square root 19, square root 19.5, square root 20. So square root of 18 is 3 square root 2, square root of 18.5, square root of 19, square root of 19.5 and square root of 20 is 2 square root 5. So 3 irrational numbers between 18 and 20. Square root of 18 and 20 means 3 square root 2 and 2 square root 5 are square root 18.5, square root 19 and square root 19.5. Thanks.